Welcome back, chat. Cool. We were looking at this problem. Do we have answers already, like right off the bat? Let me rephrase that. What is your answer that you probably already have right off the bat? What is the average velocity of this? Somebody shout it out. I actually never did the calculation, so I'm going to have to look at this real quick. Working it out. If I'm looking for V bar, my average velocity, what's my final position? 3.7, sorry. Minus, what's my initial? 6.5. And here's what I would recommend we do. It's easy to get lost in the units. We don't see yet where that's probably going to happen, but it's coming, I promise. What I like to do is, depending on how the work looks, I know that this was measured in what units? Centimeters. And that's divided by, and I like to do them just separate because sometimes they will get ugly. What was our delta T? 2.3, and that's in seconds. Now, that tells me that I wind up in centimeters per second, which is a distance over a time, so this is a velocity. Now, beyond that, 3.7 minus 6.5 is going to be a negative number. Is that okay? For sure. What is it? Negative 2.8? Negative 2.8 divided by 2.3, and we're still in meters per second. And somebody give me that number again. 1.2 what? 1.22. Negative 1.2. Now, I'm going to stick with my two significant figures since that's what I had throughout the whole problem, in meters per second. This is my average velocity. Why does it make sense that it's negative? Can velocity be negative? Because it has a size or a magnitude, which is 1.2 in this situation, and it has a what because it's a vector? A direction. Now, we weren't given any specific context. Without it, I would say left on my graph, but that could mean a variety of things. What about the average speed? 1.2. Now, there's not a good way to write it because speed isn't really anything meaningful. What I'm going to do is I'm just going to do this. Average absolute value of velocity. Cool. Now, for these, we look at 1.2 meters per second. And there are some weird situations where maybe we won't just do that. So that's really actually terrible notation. I take it back. I hate it. I'm just going to say speed. There. Boom. Average speed. Super hard. Now, when we look at average anything in physics, and really any class that you're looking at, right now we're just looking for the slope of the secant line. And we, I think, hit that language pretty hard yesterday. You need some time interval for that to happen, right? From this time to this time. Now, what if I want to know at one specific instance in time where I can't even take an interval? We had a word for that, speed at a given moment in time without taking a larger interval. What's the fancy big word? You probably recognized the root one before. Look in your notes back for like something about speed at this exact point in time. Not over an interval. Like 8 or 9 letters. It's huge. Start with the 9. Instantaneous. Now, we have instantaneous speed. Would it stand to reason then that we probably also have instantaneous velocity? The velocity at a single point in time? Like, we could probably take that too. So we'll sneak in a definition, and this is like the first new stuff today. We have a pretty chill day, hopefully. I'm pretty sure of it. So, right off the bat, we're going to sneak in that definition, and it's kind of its own little section. It's just a really small section. I'm going to define for us, and we rather are going to define instantaneous velocity. Now, for this, it legitimately takes longer probably to write the word than it does to just talk about what it means. It's the velocity at a given what? Instant. Okay, so easy. The velocity, and we can say at a given instant or at a single instant in time. Now, this again is the whole reason for calculus, because a single instant in time has no change in time, and you can't divide by 0, and there's a clear issue there. The velocity at a single instant in time. Okay, now, the way that we write stuff down, and it's one of the things I'm like pretty crazy about. We need to write stuff really clearly. The way that we denote this, or the notation that we'll use, just a heads up, if we just write V, and we can, I will probably normally include this vector notation, but if you don't, you're okay. Question?
No, I'm just trying to ask what the sign. SP.
Okay, yeah, that's my shorthand for speed. Okay. V bar, if you just, sorry, V bar is average velocity. If it says vector instead, this is what's meant by instantaneous. Instantaneous. Now, again, I will make this more obnoxious so that it's really clear. If you just write the V, it's understood that we're talking about instantaneous velocity. If you want average, what do you put above it? The bar. Or you can use a subscript and use the word average if you want to write out the whole word, but I never will. Okay. When you do motion diagrams, if we start including velocity, we have to include some sort of direction with it. Just so you guys know, I don't expect you to bring like colored pencils and pens and stuff to class. Red is the go-to for your book's velocity. In your book, red is velocity. If you want to write that down, you can. I don't even care if we pick numbers because we can just change the stuff. Like, we'll label it. Okay, questions about instantaneous velocity? Okay, so moving on, one more little thing and then a problem or two. We'll see how it goes. Everything that we've done so far has kind of been building up this intuition, and I'm going to switch colors just for fun. We have been building up intuition for the first of many to come, but we have equations of motion. Now, if we look at almost every example that we've seen, it all boils down to we might get like goofy curves and stuff, but like we had a wonky curve yesterday that I asked you to find the average velocity for. The average velocity, anytime you take it between 2 points, is going to be what sort of shape? A line. Literally every single time. Lines are the simplest mathematical relationship that you guys have probably ever seen. And it turns out that we change a little tiny bit of lettering and stuff that we use just to make it more contextually specific. But if you have passed an Algebra 1 course, the stuff that we're doing right now is totally within your realm. So, if we look back, do you guys have the example A when we went from, I might have changed the numbers. If you turn back, I guess I can just look here. I did it yesterday. We all did this example from 0, 0 to 7, 9, right? Now, even when it's a wonky path that might happen, the average is always just going to be the straight line. It's easy to deal with. So when we're dealing with this, it's a straight line every time. So we're going to make a few comments to make that as simple and clear and concise as possible, and then we'll roll with it. We know, and if we don't, we will in just a moment, that V bar, the average velocity, is a rate of change. And I'm going to capitalize this in a particular way because I use shorthands for these. Do you guys agree that velocity, just in general, is a rate of change? Because you're changing this unit per this unit. And what are the units that we typically use for velocity? So that's, you're right, it is speed. But like if I said, hey, right now I'm walking at one what? Meter, so that's not a speed yet, that's a distance. You're right though. Meter over per second, right? That's comparing a quantity, a ratio. That's a rate of change. Now, there's other language that you've probably seen. Have you ever recall seeing rate of change in a math class? So probably yes, but if not, that's okay. What word is more commonly used instead of rate of change in a math class? Holy slope. It's a slope. I'm just going to use this little implication. Slope. Now, if I ask anybody who's taking an Algebra 1 course or Algebra 2 or pre-calc even at this point, I said, what is the standard equation for a line? I am pretty comfortable that almost all of you are going to give me the same answer. Sorry. Let's look at this. I'm going to look at the algebra version of it. And then here in a minute we'll do the physics version. We'll see it's the exact same thing. The notation is all that changes. So I'm going to pick somebody random if you need like 10 seconds to chat with your neighbors. I want an equation of a line. What does that equation look like in its general form? I'm going to give you a second. I already have somebody picked. I'm going to call somebody random in 10 seconds.
So,
Yo.
can you go back to the instantaneous velocity?
Yes. The velocity at a single instant in time. All right. So we get a winner here, number Makisha. What's the equation of a line in algebra? I'm gonna shove you off here in the right direction. Y equals what if it's just a regular old line? Mx plus b. How many of you guys had the exact same thought in your head the second I asked? Probably everybody, realistically. Now, for this, I just want to label some stuff. It is up to you if you want to put this in yours. In this expression, we have an independent variable and a dependent variable and some other stuff that we're going to make sure we identify. What is the dependent variable? The y. Okay, so check it out. I'm just going to draw a little arrow and say check it out. This is dependent. What does this crazy little m thing represent? Slope. Now, I'm going to use a different word here. Instead of slope, can I call it a rate of change? How fast does y change compared to x, or while x changes? Okay, what does this x thing represent? So it is x. It's a type of variable. You're not wrong. We have the dependent y, and y value depends on what? The independent, which is our x. Independent. And this thing right here, b in this scenario, represents what? The y-intercept. Now, I'm going to write y-intercept here, but I want us to make sure ears wide open. This is the value of y when x is 0. That's all that represents. Now, the good news about this is we get our first equation of motion, and it's relating the things that we've seen. Velocity and position are clearly related, and time is thrown in the mix somewhere in there. So, when we make the transition to the world of physics instead, we get essentially the same equation. We're just going to change the letters. If we're talking about, I don't know, like speed and velocity and all that stuff, I know that the final position depends on how fast I'm going. Do you guys agree with that? So what is the dependent there if we're trying to relate like position and velocity? How fast I go determines where I end up. Would you agree? What's the dependent? Position or velocity? Louder, because all I heard was murmurs. Position. Now, gosh, if only there were like a really confusing letter that we could use to represent position in like something like this. X. Now, your book, when they present this, they just use X. I have no issue with this, but if I'm looking for where I end up, I think it's better if we call this X sub F. And what does the F represent? Final. Okay. Now, when we talk about a position changing, when we think about like that rate of change, what's the quantity of how fast position changes? Over some amount of time, typically. Rate of change, and what is it? Like right now, we did this a second ago. I'm going at 1. I'm changing my position currently. 1 what? And that's a measure of which value? Speed, velocity, displacement, distance? Careful. Velocity, because we have lines that can be positively sloped or negatively sloped, so we have to deal with those. So we're just going to look this up. If I want the nicest situation, I'm going to let my average velocity be my rate of change, or my slope in this situation. What varies throughout our problem? I'm going to make that bar a little nicer. We don't plug in x. I want to know the position at not some point in x, but some point in time. And what do we use? T. Boom. Now, only one little spot that we have to think about. When no time has passed, we can think about that as being the y-intercept if we want to. That's fine and dandy. That's a mathy version of it. Alternatively, when no time has passed, are you simply in the position that you started at? Like, check it out. Here I am. I'm going to start here. No time has passed. Am I here? And that's my what position? Initial. We see the exact same equation, just with letters changed. And we can change this any way we want. This y equals mx plus b is only by convention. This is just what everybody agreed to teach it as when we all met in our secret math teacher meetings. I don't know. We could change it to anything. Phi is rx or ry. Like, you can make it whatever you want. Okay. Now, with that in mind, let's use this. Do you want to draw the connection here? Like, do I need to draw the arrows and dependent and all that again? Okay, just as a quick check, you don't have to draw these. What does this represent? Number 2. Who's 2? Abigail. What does that represent? Okay. Number Kalisha. What does this represent? So the slope, or in the physics language, velocity. Velocity. Boom. And that bar makes it what sort of velocity? No cap. All right. T. Time, and X sub I. Initial position. Okay. All the same, everything going on. We just changed the letters to make it contextually make sense. So we're going to do a problem. Let's knock it out. I'm going to pause, do a little editing magic to shorten the video. 2 ships. Ship 1, ship 2. They're traveling at different speeds for different times, but they leave the same dock at the same point in time, and I just want to know their final positions. Now, for this, is it possible that it would help to have a picture? Maybe. Now, for right now, I'm not going to require the picture, but I'm just going to pick a couple colors so I can differentiate. We're going to have this red color be ship 1. So this is what I'll use for my color for ship 1. And we'll use this lovely blue color for ship 2. Few different ways that we could knock this out. If that's somebody's phone and you recognize it as yours, but everybody's going to have that same ding noise, I imagine. I might make you guys go check for vibrate. If it was me, I'm sorry. Okay. I want to draw this picture. That says dock, just for the record. That's super ugly writing, though. Dock. What do I draw? I don't even know how to start. Where do they leave? Am I going to spend a crazy amount of time making like a lovely dock? No. Okay, so check it out. There's my dock. It's awesome. Now, I could graph in 2 dimensions. I could have a whole coordinate plane. Do I really need it? Not particularly. So let's just check. If this is ship 1, and I'll use this red color, first thing that I care about is, I think we probably all agree, which way does it go? Up, down, left, right, diagonally. To the right, why? That's forward. I like that answer. Don't know that everybody has that same answer. Somebody has a different answer probably. Or not. I have a different answer. Why? You're right, Angel. I could already see the letter that you're about to say, I think. Were you about to say a letter that starts like west? What direction's west? Left, typically, which could be positive if you make it that way. I'm not going to call it positive right now. I'm going to call it negative. Nick, just so you know, you can do it the other way as long as you keep stuff straight. Okay, so it's going left there. I'm just going to say no scale, different color red, but we'll get through it. This is ship what? So can I say V1 for ship 1? Like you could do VS1 if you wanted to, but I think the average velocity of that ship is given. What is its average velocity? So 35, and I want you to tell me there's one thing about this that I don't love. What direction is it going? West. And on this picture, is it normally negative or positive? Left would be negative. I'm going to call it negative right now. Like I'm going to commit to it. Now with vector stuff, we don't have to go like super hardcore with it. I'm never going to make you measure. But if I do ship 2, and I'll just do it right here and it's in blue so I can keep everything straight. Why is this a terrible picture for ship 2? Ship 2 is going slower, right? The magnitude of its vector is less. I'm not going to take the time to actually measure it out, but if it's slower, that vector ought to be smaller. So here we go. Here's V bar 2 for ship 2. And I know it's negative 26 kilometers per hour. Now, when you have problems, and it's going to keep happening, where you have a lot of different information that shows up, in this case it's only 2, but we could certainly have more than this, we need to be really careful and make sure that stuff gets kept straight as we're writing everything down. So, I think we've done it before. I don't know if I've made us. What do I require you guys write on like every single problem? Have we done givens, find, and equation or work? Okay, so let's knock those out. Let's start with the given. I don't remember if we went with known or given. I'll just go back and forth. Given, and I'll try to color code these in an appropriate fashion. Let's deal with ship 1 first. Tell me one thing that you know about ship 1, number Sean. Any of the given information. What's negative? So careful. I like your language, but I want to pick something apart here. Sean says that's the initial velocity, which I guarantee. Do we have any reason to think that it ever changes velocity? So instead of just calling it the initial, which you can, it's the same as the final, I'm just going to call it its average velocity. So to represent this, I'm going to use that same notation that we have here. V bar for ship 1, which I'll just indicate with a subscript of 1, is negative 35 kilometers per hour. Anything else that we possibly know about ship 1 before I just move on to other stuff? Number Huggins.
It travels for 2.2 hours.
Okay, so love it. 2.2 hours. And here's the big question. What do I put here? T. Now, I don't want to confuse you guys. We had that equation up here. This is common. However, delta T, is it implied that that's what we mean, some amount of time? Do you want me to use delta T or just T? Because I'm cool with either. What do you think, Delilah? I'm going to let you choose. Would you write T or delta T? Okay, I'm fine with that. All right, that's all I know. All right, what about that second ship? Give me one thing that I know about it. Number Tolley.
It travels for 1.5 hours.
Okay, so delta T, and I should have done something else 2 here. I'm going to make this delta T1, just so I can keep stuff straight. Anything with a 1 is the first ship, the second one is the second. Delta T2, you said was what, Tolley? 2.5 hours. And I left an awkward gap here because I also think we know that the average velocity of that ship is what number, Barsega? 26? Can you tell me anything that I don't love about it? Good. And you might have said negative, I just didn't hear it. Okay, that's all that we know about everything. Cool. Hopefully not terrible. What are we trying to find? So I'm trying to find their final positions, and I'm really trying to stress the notation part here. How do I write down the final positions? What letter do we use for position? X. So here's where this can get kind of convoluted. The final position of the second ship, I would denote like this. X2F. And the final position of... Whoa. Why did I switch colors? Did you guys notice I did it? What's red? First ship or second ship? I hate that. I'm going to use red for X1. If you guys are just using your not colored stuff, then that's fine. And then X2F is what I'll represent the second final position with. All right. So, good news, though, is that we get an equation that maybe it's the same equation for both, and we just have to plug it in. If only there were a single equation that would allow us to find final position if I know velocity and time. Oh my gosh, I think we might. Number... I was just trying to look and see if I called in everybody yet. Number Rafa. Equation. In general, no numbers yet. Now, I'm going to do this just so we have it. And all of a sudden, by writing all this down, maybe there was some more known information that wasn't like explicitly stated that would be worthwhile. Do you know either initial position just based on what we've written down? No, so we get to pick. I could pick whatever I want, but I would prefer if we pick the easiest option. What's my initial position for either of them? Let's call it 0. Yeah, let's do that. So, for this one, this is always weird depends on how much you want to write. I know that initial position for red is 0, initial 1 position, and the initial position of the second is also 0. On mine, just so you know, I write it like this: x1i equals x2i equals 0. I just did it in one line. You do you. If we're color coding everything, it makes sense to do this. All right. I want you guys to finish this problem. Plug and chug. We're going to have one that would be red in mine, blue on yours, or sorry, red and blue on mine, and then whatever if you're coloring or not. I'm going to give you a second. Down here, I'm already going to start writing my final answer in context. Ship 1 is blank, and ship 2 is a big old blank for now. And there's probably going to be some terrible spacing in there, but we'll get by. All right, I'm going to give you a minute. I'm going to walk around, talk it out with your neighbors, with me. We are plugging and chugging. It's okay if you're struggling. Dropping bars today. Cool. Record it. While I look at this, I'm already writing in red, so that's good. Here's all that we're after. X sub 1f is equal to my initial velocity, or my average velocity rather, is negative 35. What's my time? Okay. And my initial? 0. Okay. I do not love carrying units through the calculation. I think it looks ugly and gross, but we have to do it, and it's a good thing to model. But instead of doing it here, my route, which you can write it up here if you want to include everything in there, I don't mind. I typically do this. Negative 35 is in kilometers per hour, and I'll write these units underneath so I can see that work independently without looking at the other stuff. 2.2 is in hours, and when I multiply these, I can see what happens with these hours. Good. They do cancel, but yes. Should I be left with kilometers if I'm looking for position? I think so. Kilometers is measure of distance. So checking it out. Negative 3.5, sorry, 35 times 2.2. I don't know what it is. 70? 77? Negative 77 kilometers. Is that right? 77? Okay, cool. Now, contextually, what does that mean? Ship 1 is how many kilometers? 77 kilometers. Which direction? West of dock. And I'll switch out, and I'm just going to trust your guys' math that you've calculated. Final position for the blue ship, or 2, is, let's see, we have negative 26 times 2.5 plus 0. And I'm going to do the same thing. It's redundant, but it's super helpful later on more so. Let's see, negative 52, and then half of that is 13. Is that 65? Yeah. Negative 65. And in context, meaning what? Ship 2 is where? 65 kilometers west of dock. Now, this is about as lazy of a sentence as you can get. Love it. I don't want a big paragraph there. You take your thesaurus and make it fancy. Don't care. Don't want it. These problems, like complete honesty, I feel pretty good about this. If you give me problems right now, I can do them. I hate it. I don't want to do this. I'm struggling. Somewhere, some indication, not to broadcast it to everybody, but I need to see where you're at. Okay. So, with that in mind then, let's knock it out. You guys have the privilege of working the following problems. So, today we are 912. So, that's all we're looking at. You get homework 2.4, which you will find on page 51. You get problems 37 through 44. You get about 15 minutes in class right meow. And you'll get pretty close to finishing, I imagine. Couple mathy ones, couple conceptual ones. Let's try it out. We just finished the chapter. No. Baller. Okay, so what we'll do in here. Tomorrow, we'll go over this assignment, and then we'll do a study guide together. We're not going to do a practice test yet. We'll start doing those once we get a little bit more heavy lifting. We will work a study guide in class, probably like we did the first chapter, where you guys get half the class to work through it together, and then I'll spend some time working through it. For note cards, this section, there's quite a bit of vocab, just so you're aware. I will test on vocab. It'll show up on the study guide, it'll show up on the test. You are cool to get a note card, and if you would like, we can shorten the time, maybe, to work on stuff tomorrow, so that we can make a note card together, and I'll show you what I would do, with the understanding that maybe it's different than what you would put. Sound good? All right. So as long as you guys are on task and working, I have no issue if the rest of the time is just yours. Baller.